Okay, so this is the third lesson for circle geometry, and it's going to look at the chord property. So just a reminder of what a chord is. And so a chord is any line that has both endpoints on the circumference of the circle and does not pass through the center of the circle. So that's a chord. And so the chord property we're going to look at is talking about a perpendicular bisector. So if you remember what perpendicular means at a 90-degree angle or at a right angle, and a bisector cuts in half. Okay, so into two equal pieces. And so any line that passes through the center of a circle, so that could be the radius line, that could be a diameter line, it will be perpendicular to the chord that it bisects. So it means that this chord has been cut in half into two pieces that are the exact same length. That also means that this is going to be a 90-degree angle. And so anytime you see a situation set up like this with a radius line or a diameter line cutting through a chord, you know that it will cut at 90 degrees, and you know that that chord will be split into two equal length pieces. So our first example says we have a radius line CD, and it bisects chord AB. And so from A to E and B to E is the same length. And it says that chord AB is 8 centimeters, and the radius of the circle is 5 centimeters. What is the length of the line segment CE? Okay, and so hopefully you noticed that they've given us some information. And the first piece of information they tell us is that the chord AB is 8 centimeters. And so from A to B is 8 centimeters. And so that means A to E should be 4 centimeters, and E to B should be 4 centimeters to make 8. The next thing you should notice is that they tell us what the radius is, and the radius is 5 centimeters. And so that means C to A is 5 centimeters. But that also means that any other radius line on the circle is 5 centimeters. So C to D, that's a radius line, and that would also be 5 centimeters. So that is an important piece of information we need to keep in mind. And so the radius of C to D is cutting the chord in half. It's a bisector. So we know that this is 90 degrees. And so we have a right angle triangle where we know 2 of the side lengths, and we need to know the third. So we can use Pythagorean. So I'm going to redraw the triangle outside of the circle because it's a little bit crowded in there. And if you remember with Pythagorean theorem, shoot an arrow through the right angle to point at your hypotenuse, and then label the other side lengths A and B. Oops. I don't know why it keeps doing that. There we go. So the square of the hypotenuse is the sum of the two smaller squares, but in this case we're looking for one of the smaller squares, so we actually need to subtract. So B squared equals hypotenuse squared, take away the smaller side squared. So 5 squared, take away 4 squared. Making sure you follow your correct order of operations. So you're taking care of any squares before you subtract. And so you get a side length of 3 centimeters. So that means from C to E. So line segment CE is 3 centimeters. Quite often you'll see questions like this, but they won't actually draw the radius line in, like from A to C. So be familiar with this type of question. Okay, next example. So in this diagram, A to B is 8 units. I'm going to add these in as we go. A to B is 8 units. And so because it's being cut by a radius, or I guess a diameter line, it means these two lengths are each equal pieces. So we have 4 units and 4 units. And it tells us that CD is 5 units, so that's here to there, that's 5. And so we want to know the missing lengths. So we want to know C to B, E to D, and E to F. So the first thing I'm going to find is C to B. And I hope you notice that we have a right triangle again. And in this case, we're looking for the hypotenuse. And so we're just going to use Pythagorean to find the hypotenuse. And so 41 is not a perfect square, so when we square root it, we do get a decimal and we need to round. So the question is telling us to the nearest tenth. So square root of 41, we get 6.4. And so that's for length C to B. Okay, so side length CB, or the hypotenuse, was 6.4. And so then from here we need to find some other lengths. And so I'm going to erase a little bit. Okay, so we know that C to D is 5, and we know that C to B is 6.4, and so this has actually told us what the radius is. So that means anywhere from the center of the circle to the edge of the circle is going to be 6.4. So D to E is going to be the difference between the radius and C to D. So length D to E is 1.4 units. And then the last thing we need to find is E to F. And E to F is a diameter line. So that's just 2 times the radius. Okay, and so the radius is 12.8 units. So I'm going to leave this example, this circle, for you to do. I would recommend using different colors, again, as you're trying to solve, to help identify the different lengths, and use pencil crayons, that way you can erase it if you have to. Okay, I hope that these questions photocopy dark enough for you for your notes. I know that they were a little bit lighter than I would have liked them to turn out, so hopefully you can see them a bit better on your video. So we need to solve for the missing side length. So when you find your variable, that's going to tell you the side length you need to look for. Okay. So we're looking for a radius line. And so because it's a radius line, we could find a radius anywhere around the circle, and it would be the same. So this would be the same length, or this would be the same length, or this would be the same length. I like that last piece because this is a right triangle. And so if we have a right triangle, we can use Pythagorean to try to find the missing piece. Okay, and x is actually the hypotenuse. So we're going to add the squares of the 2 smaller side lengths to tell us the square of x. Oops, I guess I skipped a step. 130.9. And so we're going to square root that. And so x has a length of 11.4 when we round. And we're rounding to the nearest 10, again, for all of these answers. So that's it. That's our missing side length. When we look at the second one, so for letter B, we've given you the diameter. So the diameter is 18.8. We've given you a little piece there, and we've told you what this length is. So half of this chord, right? If we've got a radius cutting a chord, means both of these lengths are the same. So this length is also 7.8. So we need to try and find the missing piece of x. So if we find the radius, then we should be able to find the missing piece for x, right? And so in order for us to find the radius, we're going to take 18.8 and we're going to divide it by 2. And so when we do that, we get each of these pieces. So we get 9.4. Okay. And so we could use Pythagorean if you wanted to with the 9.4 and the 7.8. But hopefully you notice that this is also a radius. And x is the difference between the radius and 4.2. So radius take away 4.2. So the missing piece is 5.2. Okay, looking at C. There's a lot of numbers going on here. Hopefully you notice that 9.7 is the radius. Okay, so we've got a radius line here, we've got a radius line here, we've got a radius line here, we've got a radius line here. On this radius line, they tell us the first part to the chord is 5.1, and then the x is the missing piece. So again, we're going to solve C, similar to B. So to find the missing piece, we're going to take the radius and take away the piece that we know up to the chord. And so x has a length of 4.6. Okay, last example. This one is a tricky one again. And so we told you that the radius is 16.7. So that's that length, and that's that length, and that's any other radius lengths on the circle. And then we tell you that this length of the chord is 15, and so if this length is 15, the other half of the chord is also 15 because it's been bisected. And we know that it's cut at a 90-degree angle. And so the trick to this is noticing that you can draw a radius line anywhere on the circle you want, and it will be the same. So this radius on this side is also 16.7. And so if we know the radius and we know another length within that right triangle, we can find the missing length. So we're going to find this length first, and then using that and the radius, we can find the unknown x. So shoot an arrow through. I know the hypotenuse, so that means I'm going to be subtracting. So 16.71 squared subtract 15 squared equals, let's just call it question mark squared. Why not? And so we get 278.9 squared. Take away 225 equals question mark squared. And when we subtract those, we get 53.9. And so to undo a square, we're going to square root. And so we get a length of 7.3. So this piece is 7.3. So now to find x, we take the radius, which is 16.7, take away the piece that we know, and x is 9.4. Okay, again, this video was a little bit longer, but hopefully that will help you. Please take a look at some of the practice questions, and we will go over these together in class tomorrow.